we basically encounter a problem about the Doppler effect. As you run toward a person, you emit a sound at a frequency of 300 hertz. What frequency does the person hear? Okay, well, let's begin by writing down the equation for Doppler shifts. So the frequency of the receiver will be basically the velocity of the sound medium plus or minus the velocity of the receiver. This is equal to the velocity of the source, the frequency of the source, basically v plus or minus the speed of the source. Now, in order to basically solve this problem, we have to basically consider this situation. So you're running toward a person, okay? And this is the source, you're the receiver, you emit some sounds. The receiver will hear the sounds. Now, you must answer the question, is it going to be higher or lower? Because you're running toward a person, the sound wave crest is going to be more closely spaced, so the frequency the receiver will get will be higher than the frequency of the source. So the frequency of the source will be lower frequency than the frequency of the receiver. That will dictate basically what sign plus or minus that we're going to choose. Right. Now we also know that the person, we're assuming this person, the receiver, is not running. So in this case, what we have is going to be f of r over v. This is going to be equal to f of s over v plus or minus u sub s. Now, because we know that the frequency of the receiver has to be higher than the frequency of the source, we must choose the minus sign here. So what we end up getting is we end up getting f of r over v is equal to f of s over v minus u sub s. Okay, now velocity of sound is 343 meters per second. So let's just plug that in. So it's going to be the frequency of the receiver, which we want to care about. 343 is equal to the frequency of the source is 300 hertz. Divided by 343 plus or minus, what was it? Well, oh wait, I should tell you is that 10 meters per second. Sorry about that. So write this down, minus 10 meters per second. And we should just go ahead and calculate this thing now. So this is going to be basically equal to 343 over 333 times 300. Right? There's a lot of 300s there. So 343, I'm not sure you can see this, divided by 333 times 300. And the answer is 309 hertz. Okay? So slightly higher frequency. That one you can definitely